Fine. Can you hear me okay?
Yeah.
Okay. I can put the microphone, usually I have it a little closer. Let me get it a little closer to my talking. Okay. Looks like we have some word problems here. Can you read that okay?
Yeah.
Okay. So they want the horizontal distance at which the t-shirt reaches its maximum height. Let me a moment to get this open. What kind of an equation is this? What do we call this?
A parabola?
Correct. And which means it has either this shape or this shape. So if it's a parabola, the maximum value of y is going to be this point right here. We know that it's a parabola that points down because of the negative sign in front of the x squared, as opposed to pointing up, the one on the right. So is all we have to do to find the maximum is to find the vertex. And we can do that in a couple of ways. We can put it into vertex format, or we could use minus b over 2a. Which do you think's easier? Marina? Hello? I lost.
Hello?
Yeah, okay, now I can hear you. I couldn't hear you for a second.
Oh, okay.
Okay.
What did you ask?
Well, we need to figure out the vertex because that's going to be where y, remember this is on some scale here, and this point right here is going to be where y reaches a maximum. And that's what they're asking, where y represents the vertical distance and where find the horizontal distance where the t-shirt reaches its maximum height. I'm going to turn my camera off again because I'm having more difficulties. Okay.
Okay.
So how are we going to figure out where this point is?
By using negative b over 2a.
Okay, so what is minus b over 2a? And remember, that's going to give us the x-coordinate, but that's actually what they're asking for, because the horizontal distance is the x value. So what's minus b over 2a equal?
16.
No, it's minus 4.
Well, minus 4 over
Minus
negative 0.25.
Uh-huh. And all of that is plus 16. Okay. So this parabola must be over here, not on the left side of the y-axis, because that peak occurs at that point right there. So 16 is the answer for A. Find the maximum height of the t-shirt. What is it? What's the y value going to be here?
equation
Yep.
and
So set it up for me. I don't really care if you do the arithmetic, just set it up. So it'd be minus 1/8
times 16 squared plus 4 times 16.
Right. Once we get to that part, I'm comfortable you can figure it out from there. You can always use your calculator, but let's go on. Let's go on. Graph the equation of the t-shirt. Clearly plot the vertex and 2 additional points. Okay, well, we've kind of graphed it here. Let's see. I guess we do need to know a number. Let's see. 16 squared is 256 divided by 8 is 32. So this is minus 32 plus 64. So this height is 32. Okay, so our graph isn't quite drawn to scale, but as long as we label the points, we'll be fine. So we know where the vertex is. What other 2 points should we find?
The x-intercepts?
Yeah, it doesn't say, it says clearly plot the vertex and 2 additional points. So it kind of gives us our choice. We could plot point 17 and point 15 if we wanted. And we would plot those by plugging in those values for x and figuring out that y was the proper value. In fact, we really only have to plug in 1 because we know it's going to be symmetrical about that x-axis. So the easiest way to actually solve this problem is to plug in 17 or 15 for x, come up with a y value, plot it, and then go symmetrically across and plot that point, which would be 17 comma the same y value. And that's all she's asked you to do. However, typically in these kind of problems, they do want you to find the x-intercepts. And that's the points. If she were to spell it out, she would have said plot the vertex and plot the x-intercepts. I'm guessing. So how do we get the x-intercepts?
The quadratic formula?
Well, what equation do we have to solve in order to solve for the x-intercepts? What is y when this graph crosses the x-axis? What's the value of y?
0.
Yeah, so what we really have to do is solve this equation. If we solve this equation, it'll tell us the values, and it looks like there's 2 of them. It'll tell us which values of x make y equal to 0. Well, first thing I'm going to do here is get rid of this negative 1/8. So I'm going to multiply every part of this equation by 8, which gives me 0 equals x.
Just by 8?
Yeah, if I multiply it by negative 8.
Oh, yeah.
Okay, so now I've made it simpler. Still haven't solved it. Now I don't really need the quadratic. I don't need to factor this like I would factor a quadratic if there was a constant in it. How else can I factor this? I'm going to start writing it over here where I have more room. So I'm going to say x squared minus 32x equals 0. What's the best way to solve that?
You divide it by x?
Factor out an x. Now, what are my two solutions?
X equals 0 and x equals positive 32.
Okay, now I can draw my graph better because I know that it's going to go through this point, it's going to go through this point, and it's going to go through that point. Notice the flatter. This parabola is flatter than most, as it should be, because this coefficient is 1/8, which means it flattens out the normal-looking parabola, as opposed to making it skinnier. Okay?
Okay.
All right, on to number 2. Number 2 is very much like number 1. In fact, it's exactly the same as number 1. So let's see if you can do it from start to finish.
Hello?
Yeah. So
Sorry, I didn't hear what you said.
let's see if you can do it from start to finish. It's exactly the same as problem number 1. In fact, it's got close to the same numbers. The only difference is the coefficient is 1/10 instead of 1/8 and 1 instead of 4. But so how do we find out where this parabola reaches its maximum height? We'll call it the x-coordinate is equal to what? What did we use last
You're
time?
on TV, so I didn't really hear it.
Minus b over 2a. So let's plug that in from the equation. Can you read it?
Sorry, I'm writing it down. Okay. It'd be 1 over...
It's minus b. So it's minus 1.
1 over 2 times 1/10.
And it's a negative 1/10. So that would be negative 2/10 or 1/5. And what's this equal to? How do you divide 1 by 1/5? How do you divide by a fraction?
I don't know.
You flip it and multiply. In other words, negative 1 divided by negative 1/5 is the same as negative 1 multiplied by negative 5 over 1. And now I just multiply numerators and denominators and I get 5.
Oh, okay.
Okay? You got 16 in the first one by doing exactly the same thing. You divided 4 by 1/4 and came up with 16. This was the same thing. Okay, so 5 is the answer to A, part A of the second question. In other words, when x equals 5 is when we're going to find this peak that we found on the previous function. We don't know where it's at yet. For the moment, we'll just leave it as x equals 5 as the line that's going to run right through the middle of that vertex. Now find the maximum height of the water. That's finding y of 5.
So replace x for 5.
Okay? Help me do this math.
So you get negative 1/10 times 25 plus 5.
Okay, negative 1/10 times 25 is what?
25 over 10.
Negative 25
Negative
over 10.
10.
And then plus, to add 5 to it, I'm going to make it 50 over 10 to give it the same common denominator. Instead of writing 5, I'm going to write 50 over 10. And now I can add those two, and I get plus 25 over 10, which is 2 1/2. So the value of y when x is 5 is 2 1/2. That's the height of that drinking fountain water. Now graph the equation, clearly plot the vertex and 2 additional points. So again, let's see, our vertex is at 5, 2 1/2. I'll try to make it a little more accurate this time. Right there. 5, 2.5. And help me solve for the x-intercepts. How am I going to do that again?
Replace the y with 0. So 0 equals negative 1/10 x squared plus x.
Okay, and then how do I solve this? What's the first step to make it simpler?
Factor by x. Or factor x.
Let's get rid of this negative 1/10. How do I do that? What do I need to
multiply by 10.
By negative 10.
Negative 10.
Because I want to get rid of the negative sign and the 1/10. If I multiplied it by 10, I would still have a negative sign. So I'm going to multiply both sides of the equation by negative 10.
So that equal x squared minus 10x.
Okay, and 0 times negative 10 is still 0. So now what?
Factor x.
And what's my two solutions?
X equals 0 and x equals positive 10.
So now I can draw my parabola. Again, it goes through 0. Okay. Let me pull up the other email here. This one may test my vision. Wow, this is a little bizarre. I wonder how you get it to do that. It's clear up top and fuzzy at the bottom.
That's weird.
It is weird. Usually it's the same throughout. I wonder if the camera was held. These were taken with a cell phone camera, right? Or were they?
Yeah, that was an iPhone.
Wonder if she was at a little bit of an angle, maybe. I don't know. We can make them out. Okay, go to Big Ideas Math, Purple Book, Functions, watch the lesson tutorial. Okay, presumably you've done that. Now do the following problems for classwork. Graph the function, describe the domain and range, and compare it to the parent function. All right. You might have to read some of these to me, but that's okay. They're easy to verbalize. All right, let's start with A. Y equals 2x squared plus, what is that letter? 4x plus 1. Graph the function, describe the domain and range, and compare it to the graph of y equals x squared. Okay. There's various ways we can do this. Since they want us to compare it with y equal x squared, let's try to get it into a format of y equals x minus h squared plus k. Or y equals a times x minus h squared plus k. That will be in vertex format. We will easily be able to compare it with y equal x squared, and we'll be able to graph it once it's in vertex format, and we'll be able to describe its domain and range. So, how do we get this in vertex format? We're not going to use the minus b over 2a here. That would let us figure out where the vertex was, but it would not get it into vertex format, which we need to compare it with the graph y equal x squared.
I was gone when we learned the graphing transformations,
Okay.
so I don't know how to solve it by graphing.
Okay. Well, let's first of all complete the square. Now, we're going to work only with one side of the equation because the other side says y, so I can't really do anything with that. And I don't want to set it to 0. That would only solve for the x-intercepts. However, I want the right side to look like this. Does this look familiar? That's vertex format for a parabola or a quadratic. Once I can get it into this format, then I'll know the vertex is at h comma k, and I'll know its domain, I'll know its range, and I'll know that it's a transformation of y equal x squared. It will have been moved over some amount h, it will have been moved up some amount k, and it'll have been stretched by a factor of a. So our goal is to take this equation and get it into that format. And the way we're going to do it is we're going to complete the square. Okay, let's take this and write it here. Now, the first step for completing the square is to get rid of the coefficient from the x squared term. I can factor out a 2, but I'm only working with this part right here. I'm going to leave this plus 1 over by itself for a while.
Okay.
Okay? So what do I get when I factor out a 2 here?
Like divided by 2?
Well, I'm factoring out a 2 from this, what I've got in parentheses here. What's left over after I divide by 2? You're right, it's division by 2, but I like thinking of it more as factoring rather than dividing. But that's how you figure out what's left over, is you divide this by 2. So what's left over?
X squared plus 2x plus 1.
Okay, and I'm going to leave some space here. Because remember, completing the square, I have to add something here. So I still have this plus 1 I'm going to leave out here like this. What do I have to add inside the parentheses?
+1.
Okay. When I do this, so far I haven't changed the equation at all. But the moment I do this, what have I done to the right side of the equation?
Added 2.
So what do I have to do to balance it out to the right side of the equation?
Add 2 to the left.
No, remember I'm not going to touch the left. I'm going to do everything on the right. So I just added 2, so I got to subtract 2. Now the equation is still balanced. Now this part right here is exactly the same as this part here. Okay? With me?
Yeah.
Okay, now we almost have it in this format up here. How else can I write x squared plus 2x plus 1? What's the
x plus 1.
quantity squared? In other words, my whole point in completing the square to get this thing to look like that was so that I could write it x plus 1 quantity squared.
But what about the +1 minus 2 on the outside?
That now becomes minus 1. I just combine them. Now I have it in this format. So A is what?
Is 2.
H is what?
1.
No, it's got to be x minus h. We're looking at an x plus 1, which means h has to be minus 1. If h were minus 1, it would look like x plus 1 because it would be x minus a minus 1, which turns into x plus 1. And what is k?
-1.
Correct. So now we have our vertex right there. At -1 plus 1, -1 minus 1, and this opens up because there's no negative sign. A is not negative. If A were negative, it would open down. So I need 3 points, I guess. No, I don't. Yeah, I guess I do. You always need 3 points? What's the easiest point to find at this point?
The vertex?
Well, we've already found it. Here's the vertex right here, -1, minus 1. But to graph any parabola, you need 3 points. 3 points define a parabola. I could solve for the x-intercepts and do it that way, but that's kind of hard to do actually, because you have to set y equal to 0 and solve for both x solutions. There's actually a far easier way to get another point.
Replace x with -1.
Well, how about replacing x with 0 and solve for the y-intercept? I can tell this is going to have a y-intercept. In other words, if I can figure out the y-intercept, I'll also know that the point opposite it, symmetrical, will also be a third point, and I'll be done. So if I substitute 0 for x, what do I get? Solve this equation right there. Just plug in 0 for x and solve it. What number do you get?
1.
Okay, that means that my graph not only has to go through this vertex, but when x is 0, y has to be 1. So it's got to go through that point right there. So what is this point right here that I know is symmetrical? What's the... I know this point here is 0, 1. What's this point over here that I don't have to figure out? I just have to notice that it's equidistant from a vertical line that if I draw through the vertex. So what would its x-coordinate be?
It'd be 2,
Minus
1.
Minus 2 comma 1. Correct. So to me, that's the easiest way to graph these, is to find the y-intercept and then know that this point is symmetrical. So it has to be the same distance about this line of symmetry. In other words, this distance has to be the same as this distance. So this is easier math always, and you only have to find one point, and then the other point pops out at you. So that's my favorite technique for graphing parabolas. Now let's talk about the domain and range. What's the domain on this function? Let's look at this thing right here. That's the easiest to figure out. Domain and range. We talked about domain and range last time.
Yeah.
I'm going to leave the graph. Let me get rid of it. What's that? Go ahead. What'd you say? Marina, you there?
All real number?
For the domain, yes. And I can get that two ways. I can look at the function and realize that x can be anything. There's nothing x can't be. It can be 0, I'm not dividing by it, I'm not taking the square root of it, I'm not doing any of that. So x can be all reals. I can also look at the graph that I just drew and realize that if I go far enough up, x is going to go far enough to the left to get to infinity, and same thing on the right. So I can read the domain from the graph. How about the range? The range is easier read from the graph than it is figured out. Let's do it both ways. When you look at that graph, what is the range? Remember, the range is the possible y values. What's the lowest?
Problems with range.
Well, look at the graph. What's the lowest possible y value that shows on that curve?
-1.
Correct. What's the highest possible y value?
Oh yeah, I remember my teacher, she said that, like, she likes us to put
Bracket.
y equals, y is greater than or equal to -1, or less than or equal to whatever number.
Okay.
Like, she likes us to put in the equation.
That's actually the range, right there. That also means that y can go from -1 to infinity. You see that?
Yeah.
Okay. Now, how could we get that same information from the formula itself, the equation, without, if we didn't have it graphed, how would I know? I'm going to erase this graph. How would I know from the formula what the range was from analyzing this? What happens to this part of the number as x goes from -1 in either direction? In other words, if I plug in x equal 100, this whole thing's positive, right? What I have circled?
Yeah.
If I plug in -100, this whole thing is still positive.
Yeah.
So we can't make the part that I have circled negative because it's something being squared. No matter what is the value of what's inside the parentheses, when you square it, it becomes positive. So even if it was negative to begin with, it's going to become positive. Which means when you're trying to figure out how low y can go, start with the fact that this can only start at 0. And that's only when x is equal to minus 1. But this part can never be less than 0, which means this part can never be less than minus 1. Same thing we read off the graph. Much easier to read it off the graph than to try to figure it out. But if they gave you the formula and asked you domain and range, it might be easier to figure it out than to try to graph it and figure it out. So it's worth knowing how to do that. All right, let's look at another one. Oop, I didn't mean to erase that. I'm going to give you a hint because I'm going to put that 7 way over to the right. Remember over here on the far right, this is what we're trying to make it look like. Okay, what's my first step? Marina?
Yeah?
What's my first step?
Finding the vertex?
No, we're going to complete the square because we want to get it into this thing here. So let's complete the square. We complete the square using just that part there. How do you complete the square?
Sorry, hold on a sec. You factor x from x squared minus 8x?
No. You take half of the coefficient of the x term. What do you do?
Times square root?
When I'm completing the square, I take half the coefficient, which is minus 4, and I square it, and I add it. So I'm going to add 16, and since I have to leave the equation balanced, I have to subtract 16. Why did I do that?
To make it balanced.
I did it so that I can express this how? I subtracted 16 to make it balanced, but the whole reason I'm completing the square is for a very specific reason. What is it? So that I can express this in this format right there.
Oh, yeah.
So what is it?
It's x minus 4.
It's always that number that you got when you divided that by 2. So you don't have to go back and factor it. Just remembered what number it was that you took half of and used that. or the square root of the constant that you added. Either way gets you this. Okay, now I combine these two. What do I got left?
Minus 9.
So now I got y equals, and I've got it in vertex format. That's perfect vertex format. A is 1. So where's the vertex?
-4 and -9.
Got the -9 correct, but it's positive 4. H is the x coordinate of the vertex. We're trying to get it into x minus h format. So it's x minus 4, which means h is a positive 4. So the vertex would be right there at 4 and -9 right there. So it's going to go up. Again, let's figure out the y-intercept.
So replace x for 0.
Okay, what do you get?
7.
Okay, so when x is 0, y is 7. So that point's on the parabola. So we know the parabola goes like this. What's this value right here? This point right here is 0, 7. What's this point here as our third point?
It's 8, 7.
Okay, good. What's the domain?
All real numbers.
What's the range?
Y is greater than or equal to -9.
Good. Now let's talk about one thing that we forgot to talk about on A, and that's how does this compare with y equal x squared? This is exactly the same as y equal x squared, but it's been moved up and down, and it's been moved right and left. So you can figure out what's happened to it by looking at this. This amount here is how far it's been moved to the right. This amount here is how far it's been moved up or down. I should have said this amount here is how far it's been moved right or left. Since h is positive, it's been moved to the right. And then the whole thing has been vertically shifted down by 9 units. So the parent function looks like this. And this function that we drew has clearly been moved to the right 4 units and down 9 units. So that's the transformations that it's had done. Okay? And we could have read that from the graph that we drew, but it's actually the easier way to read that is from the function itself.
Oh, okay.
Okay, let's do C. Here's what's our standard vertex format? How's that read? Y equals what?
For number C?
No, just the standard. I've been writing it on every problem.
Oh, y equals x minus h squared plus k.
Right. That's what we're going to try to get C into. And here's what we're starting with. Y equals minus 5x squared minus 10x minus 2. What's the first step? How are we going to do it? We're going to complete the square. What's the first step in completing the square here? And remember, we're only going to work with that part of it for the moment.
Divide by 5x.
Okay, what's left?
X. Wait.
We're not going to divide by 5 minus 5x. We're only going to factor out the minus 5 because in order to complete the square, this must be a 1.
So it's negative 5 times x minus 2x minus 2.
It's negative 5 times x squared minus 10, plus 2x. So right there, we haven't changed anything. We still have the minus 2 sitting out here. So I've gone from this step to this step without changing the equation. That's the whole point. And I'm now set up to complete the square inside the parentheses. So how do I do that?
Plus 1.
How do I balance?
Minus 1.
How do I balance the equation? Not by minus 1. I didn't just add 1 to the equation. I actually subtracted 5 because that plus 1 is being multiplied by this minus 5. So what I really did was I just subtracted 5 from this side of the equation. So what do I have to do?
Add 5.
Okay, now how can I write this? Remember, I'm trying to get it into this format.
Negative 5x plus 1 squared.
Quantity squared. When you verbalize these, you want to put that quantity because otherwise it looks like this, and that's different. So that's why you need to say the quantity. And then what's the rest of it?
Plus 3.
Okay. Where's my vertex?
1, 3.
Negative 1? Let's examine that because you seem to be confused on that. So I say that h is a negative 1. Remember, the vertex is not minus h. The vertex is at h. Whatever h is the vertex, and k. And by using minus 1, what I'm now saying is I have x minus a minus 1 quantity squared. Well, that's the same as x plus 1 quantity squared, and that's what I have, is x plus 1 quantity squared. Therefore, working backwards, h must be minus 1. And the plus 3, I've got plus k, so k is also plus 3. Okay, so this thing goes which direction, up or down? this parabola?
Down.
Okay, good. So first of all, let me find -1 and 3. So there's -1 and 3. How do I get 2 more points?
Replacing x for 0.
Okay, and what does that give me?
The y-intercept.
Well, what number does that give me when I replace x with 0?
-2.
Okay, so this point is on the curve. And what's my third point on the curve? Is that point right there?
Oh, 2, -2.
-2. Look which side of the axis it's on. It's on the left side of the y-axis.
Oh, -2, -2.
Okay. And then my curve looks like this. What's the domain?
All real numbers.
What's the range?
Y is less than or equal to 3.
Correct. Okay. Good. You're getting better at these. Okay. Let's do a more complicated looking one. I was going to say let's do the most complicated looking one that's left, and I think it probably is D. So we got y equals, is that -1/2? Plus 8x? Plus 20? Okay. What's my general format? My vertex format?
Did you ask me what my vertex was?
What's the general vertex form that we're trying to get this equation into? A times...
Multiply it by 2.
A times what?
Oh, A times x minus h
Squared.
Plus k.
That's the, you want to start out every problem with that. So try to memorize it. You're not going to be able to look it up every time. You got to memorize that. Okay, so how do we get this function into that format? What method are we going to use? What's it called?
The vertex format.
How do we get this quadratic function into the vertex format? There's a technique you got to use.
By factoring?
Completing the square.
Oh yeah, completing the square.
So how do I complete the square here?
Well, first you have to multiply everything by 2.
Actually, you got to divide everything by -1/2. In other words, whatever this coefficient is, we got to get rid of it. I get rid of it by factoring out a -1/2. You've been calling it divide, which is okay. That's not a bad way to look at it. It is division. And what's left over?
X squared plus 8x.
Okay, I'm going to divide 8x by negative 1/2, right?
Oh, by 4x, negative 4x.
No, what is this? What is 8x divided by negative 1/2? How do we divide by fractions?
Put 8 over 1.
We flip the denominator and multiply. So what is this equal to?
Negative 16.
X.
Oh, yeah, negative.
This is negative 16x. Now we haven't changed anything. The function is still exactly as it was. We've just rearranged it. So how do I complete the square in the middle?
Sorry, that was my mom.
Okay. How do I complete the square in the middle?
Subtracting 4.
Remember, I take half of this coefficient.
Oh, yeah.
It's called completing the square because I take half of that and square it.
Subtracting 64.
Except I'm always adding. When I complete the square, I'm always adding inside the parentheses. Because notice when I take half of that, I get minus 8, but then when I square minus 8, I get positive 64. So this is always a plus 64. I mean, this sign is always plus when we're completing the square, no matter what that sign is. Now what do I have to balance it out with? Because I just wrote in a plus 64 there.
Subtract 64 times 16.
64 times minus 1/2,
I mean 1/2.
which is 32. So now how can I rewrite it?
Negative 1/2 times x minus 32.
Remember, it was half this number. In other words, when we were completing the square, we took half that number and squared it to write that 64 in there. So let's just go back to what we did. Whatever that half of that was, that's what we're going to write there. So where's the vertex?
X minus.
No, the vertex is at a coordinate. What are the coordinates of the vertex?
Oh, negative 8.
No.
And
Positive 8?
Positive 8 and
Negative 12. Because remember, the standard is this. If the standard is x minus h, then h has to be positive 8 for this to be x minus 8. That's h right there. Okay? All right, so we got a vertex. We only got another minute or two here. You know how to find the y-coordinate, or the y-intercept, by plugging in 0 for x. However, let's talk about how this compares to y equal x squared. This time we got 3 things going on. What's the consequences of this in the way of translations and shifts? Marina? Marina?
Can you hear me?
Now I can.
Oh, okay.
So what's the consequences of the -8 in the way of a translation or a shift?
What do you mean?
Well, this has a certain meaning. In other words, we're looking at a function here that is the same as y = x squared, only it's been shifted right and left. It's also been shifted up, down. It's been reflected about the x-axis, and it's been fattened by 1/2, or by a factor of 2, actually.
Oh, it's been shifted to the left 8
No,
times?
to the right. Because,
to the right.
again, from this point forward in your math career, this is almost always what you're going to see. X minus h, not x plus h ever. It's always going to be x minus h. So get used to seeing that, and then knowing that this translation is a +8, which means a shift to the right of 8. Positive goes to the right. What's the vertical shift? Which is an up or down shift. In other words, neither this horizontal translation or this vertical shift change the shape of the curve. They leave the curve exactly as it was. This goes down 12.
Oh.
What's the consequence of this right here? That negative sign. Causes a reflection over the x-axis. So instead of the curve looking like this, it would look like this. That's what happens when you reflect it over the x-axis. It's like a mirror reflection. And finally, what are the consequences of this 1/2? Do they make the parabola?
It widens.
It widens it, exactly. Makes it like that as opposed to like that, by a factor of 2. Okay, let's end it there. And we'll pick up, let's see, if I look at my calendar here, I don't see you again until next Monday at 4:30. Okay?
Oh, okay.
I will text you the ID meeting next Monday.
Okay, thanks.
All right, Marina. Bye-bye.
Bye.